In this problem, we have a 3.1 voltage source, and it's applied across 3 resistors that are in series. We're then asked what is the voltage across the 11.1 resistor in volts. So we can make a diagram of this. We have our 3.1 voltage source. So this is going to be our voltage source where we have the longer side is positive and then we have negative right here. This is 3.1 volts. And so it's going to be connected to 3 resistors in series. We're just going to draw them below like this. So that means we have some current flowing out of our voltage this way. And so with that in mind, we can look at our resistors. So when we write this out, we have 5.7 kilo ohms of resistance for this first one. This next one, we are going to have 3.1 kilo ohms of resistance. And then for this last one, we are going to have 11.1 kilo ohms of resistance. Now we need to find the voltage across 11.1 the kilo ohms, but the voltage, when we put it through series, it does not stay the same. It breaks up among these three. What is the same with the resistors in series, with ideal resistors, is current. So what we can do is find current. We're going to use Ohm's law, where we know that we have the voltage is equal to current times resistance. So we're going to find our current total. Current total is just going to be equal to the total voltage divided by the total resistance. So we have 3.1 divided by all of our resistors down here. And I'm just going to call that R total. And if we do that, it's going to look something like the following, where we have our 3.1, again, this is the total voltage, divided by all of our resistors. Now the reason why we have everything multiplied by 1,000 is because we have the kilo ohms, and because of the kilo is 1,000. So that is going to give us this answer, approximately 0.00015. That's just the current, and from here what we're going to do is we are going to take this current, multiply it by this resistance, and get the voltage over here. So this is step 1, and we'll do step 2 down here. And step 2 is saying, well, we know that we want to find the voltage over our 11.1 kilo ohm resistor. So we're going to need the total current, because again, current is the same through series, and this is being multiplied by the resistance that's at the 11.1 kilo ohm resistor. All of these are specific except the current, again, because current is the same throughout resistors in series. If it was in parallel, it would be a little bit different. So what we can do is take this right here, and I'll actually highlight it like this, and we are going to plug it into here, and we're going to take this and we're going to plug it into here as well. So knowing that, we can go back to our calculator and we can paste it in here. This is our resistor, 11.1 times 1,000. That's going to give us a value of approximately 1.729. So our answer is going to be approximately 1.729. And that is how we would go about solving for this problem or anything like it.